Hello guys, this is the TI-84 guy. I'm back again. I just did a video where I went through the A-linear program and I worked several problems from the Math Level 1 and Math Level 2 practice exams. I'm going to do the same thing, but this time I'm going to focus on the quadratic problems that I found on the Math Level 1 and Math Level 2 exam. And I want to show you how the quadratic program that I've written will help you. So let's jump into it. I have about 5 questions that I'm going to do, and then I'll tell you how to get the program. So first thing, I want to go through this again. Essentially, I took the problem from the official subject test study guide for Math Level 1. I also used the Math Level 2 study guide. I also used the teacher's guide. I pulled a few questions from there, and then I also used the SAT subject student guide. Now, the subject student guide is a good resource if you don't have the other study guides already, but I would definitely recommend, if you're preparing for the SAT, Math Level 1, Math Level 2, that you should pick these books up because they have 4 practice exams in them, okay? You could also find this on the internet. I'll put a link in the description on where you can find this. I'll also include a link on where you can find this. So I'll put that information in there. All right, so let's jump into the problems. Let me get this oriented. All right, so let's read this and then I'm going to go through it. It says a ball is tossed into the air and the height of the ball above the ground at different times is recorded in the table above. And then it says a quadratic regression is obtained for these data with height expressed as a function of time. Okay, according to the regression equation, what is the maximum height of the ball? So essentially what we're going to have is we're going to have an inverted parabola, and they want us to find the vertex, and they want us to focus on the y coordinate, because that represents the height of the ball, the maximum height of the ball. Now, as I mentioned in the last video, if you had a chance to watch that, and I'll include the link for that video up here. The Math Level 1 and Math Level 2 exam, there are a lot of regressions on there. When I went through and was looking at the problems, there was usually 1 or 2 regressions per exam. On the SAT or the ACT, there basically aren't any regressions that you have to come up with the equation like that. Okay, but in this case, we're trying to come up with the regression. So this is what I would do. Let me share my calculator. Now, once I know I'm dealing with a quadratic, I'm going to go to the quadratic program. Now, it's called QUADRATE. If you have the CE calculator, if you have the 84 Plus or the 84 Silver Edition, you would use something called a quadratic. It's slightly different, but they basically have the same functionality. The QUADRATE program is a little bit more flexible in that you can enter fractions and decimals, because the TI-84 CE has a little bit more bandwidth on the screen that you can use. So that's the only difference. But anyway, it would be the QUADRATE, press enter. Now, in this case, we are trying to generate an equation. Now, the way that I've written this program, I've said that in order to come up with any quadratic equation, you need to know at least 3 points. Now, they've given us 4 in this example, but I'm only going to enter 3, and I'm going to show you that that's enough to answer this question. So I'm going to press enter, and then I'm just going to enter the 3.0, 5, and then 0.5, and the y coordinate is 17, and then we have 1.5, and then 20.5. Okay, so I press enter, and in this case, I want to try to put this quadratic regression, I want to try to put it in the vertex form, because once I can get it in the vertex form, the vertex form is going to tell me not only what the x-coordinate is of the vertex, it's also going to tell me the y-coordinate. And in this case, we're looking for the y-coordinate. So I would choose option 2. And now look at this. This is in the standard form, and it has all of these fractions. And this is the vertex form. And what we're interested in is, I want to show you the part. We're interested in this right here. Actually, it kind of spills over to the next one. So basically what we're looking for is 44. It's kind of hard to write with a cursor here. 44,065 divided by 1968. That's a 9, 8. Now, so basically all I'm going to do is I'm just going to key that in, and that's going to be the maximum height. So let's just do that. We're going to, let me get rid of this. I'm going to put 44065 divided by 1968. Press enter, and that's the height. That's the maximum height. We're rounding it to the nearest tenth, so the maximum height would be 22.4. So if I go back to the exam, I would choose letter D. All right, that's the question. That's the answer to this question. I used a quadratic regression, and I put it into the vertex form, which is very slick. Once you have it in the vertex form, the y part is going to be your answer. All right, let's keep going. All right, so here's another one. It says, in the xy plane, which of the following is an equation of the parabola that passes through the points? And they give us 3 points. Now notice, whenever you are trying to come up with a quadratic equation or a quadratic function, they have to give you 3 points, right? They have to. If they only give you 2, that's not enough information. They have to give you a minimum of 3. They've given us 3, so we would go back. Let's go back to the calculator. And let's go program. We're going to choose 0 for quadrate, press enter. And again, we're going to use option 4 for 3 points, and the 3 points were a -2, 0, and then it was 1, 9, and then we have 0, 8, and then you press enter. We want it in the factored form because that was the way that all of the answer choices are. So we're going to factor it. And so it says the standard form is this. The output would, the factored output would be this. I notice there's a negative in front here, x minus 4, x plus 2. So if I go back to your, to the exam, it would be this one. Let me double check that. I want to make sure I selected the right one. I didn't write the answer down on my, so negative x minus 4, x plus 2. Yeah, I'm glad I'm going back because it's actually, I actually chose the wrong one. Actually, it's not this one. It would be this one. Now notice that my program put the x minus 4 first and x plus 2, but since it's multiplication, the order really doesn't matter. So that's your answer, okay? Let's keep moving because I want to try to keep this relatively short. All right, it says in the xy plane, the minimum point of the function f defined by f of x equals x squared minus 4x minus 12 is rs. So this is the vertex, and they want to know what the x-coordinate is of the vertex. So this is a pretty straightforward question. I would go to my calculator. I would press enter. They gave us the quadratic function in standard form. The leading coefficient was a -4. The b term would be also a -4. Whoops. Actually, I messed that one up. Let's try this again. I'm going to quit. I transpose that. So the standard form, would be 1, and the B term is a -4, and the C term is a -12. Press enter. We want it in the vertex form. And so the vertex, the X value is 2, the Y, or the X coordinate is 2, the Y coordinate is a -16. So if we go to the exam, we would choose C. All right, pretty straightforward. Nothing too complicated about that. Now, here's another one. This was taken from the Math Level 2 exam study guide. It says, for what value of k does the equation x squared plus 6x minus k equals 0 have equal roots? And what this essentially means, let me move this out of the way, is basically they want to know if this blue line represents the x-axis, the quadratic is just tangent to that at one place. So you have a double root right here. So we want to know what value of k do we need to use. Again, what we can do here is we can basically put this into the vertex form, and that'll tell us what we need to put in for k. So let's do that. So I'm going to go to the calculator again, press enter, and I'm going to enter it in standard form. The A term is 1, the B term is +6, and we don't have a C term. That's what we're trying to figure out. So I'm going to put a 0 in there. And then I'm going to put it into the vertex form again. So I'm going to choose option 2, and it tells us that we basically have to add a 9 there to put this into the vertex form. So if we go back here, that would be, which part are we using? Is it going to be 9 or is it going to be a -9? So if I put a -9 in here, a negative minus a -9 would be a +9. If I put just a 9 in here, this would be a -9. Now, if I go back to my calculator here, it's saying that if you multiply this out, this part, this is going to be x squared plus 6x plus 9, and then we got this -9, right? So basically what we want is this. Let me see if I can write this. I'm going to annotate on the screen. So this is going to be x squared plus 6x, and then 3 times 3 is going to be a +9. So that's the form that we want to get it into, okay? So if we go back over to this, that means that we have to use this -9, because a -9 becomes a +9. So the answer for this one is -9. Now, this one you just have to be careful with. Now, the actual using the program, it's pretty simple to come up with the vertex form of this. But what you got to be careful about is it going to be the 9 or is it going to be a -9? And I hope you can see that you should choose the -9 here. Okay. I have one more question and then I'm going to be finished. This is another pretty simple, straightforward quadratic. They've given us the quadratic function in standard form, and they just want to know what the x coordinate is of the vertex. So basically, it's what we've done already 4 times, but I'm going to do it one more time. So here, press enter. The input is in standard form, so we're going to go a -6 for the A term, a +3 for the B term, +8 for the C term, and then we want to put it in the vertex form, and it's telling us that the x coordinate is going to be 1/4, or you can say 0.25. The y coordinate would be 67/8. We don't care about that. We only care about the x. So we would go back to the exam, and we would choose a positive 1/4 or 0.25. So that would be our answer. I hope that that is clear, and I hope that you guys see the value of the quadratic program for the Math Level 1 or Math Level 2 exam. That's the last one. Now, if you'd like to get a copy, let me get rid of this. If you'd like to get a copy of this program, 4 things. I need you to send me your email address. Make sure you spell it properly. And tell me what kind of calculator you have. Is it a TI-84 Plus? Is it a TI-84 Plus Silver Edition? Is it a TI-84 Plus CE, the Color Edition? Is it a TI-83? Tell me what kind of calculator you have, because depending on what calculator you have, that'll tell me what program I need to send to you. Third thing, and please subscribe to my channel. And if you could like the video, I'd appreciate it. Likes attract more eyeballs. I'm trying to help as many students as I can on these exams, do as well as they can on these exams. A like is just a way to communicate to other students, hey, come look at this. This is something that you might want to use. So I would appreciate if you could do that. All right, if you give me your email address, I will try to get you the program probably within 24 hours unless it's really hectic here. It might take me a couple days, but I usually try to turn it around within a day or so. So, all right, guys, I hope you see the value of not only the quadratic program. Let me tell you the name. It's called QUADRATE. It's called QUADRATE if you have a CE. If you want the version for the TI-84, it's going to be called the QUADRATIC. It's just the last 2 letters, or the last letter is different depending on what kind of calculator you have. So tell me what kind of calculator you have, and I'll know what to send you. All right, guys, peace, and I hope you guys stay safe.